Hello, geometry students. Mr. Zacek back and better than ever here in Unit 8, Lesson 2. We're going to be talking about special right triangles. And we've got two special right triangles that we're going to look at today. The first is a 45, 45, 90, which also, the other way we want to recognize the 45, 45, 90 is it's also an isosceles right triangle. So both of those will be this relationship. So we're going to look at explore the ratios between the sides of a 45, 45, 90 triangle. And I'm just reading along here. Any triangles with these angle measurements will be similar. Therefore, the ratios between the corresponding sides should be the same. So similar because of the angle-angle similarity postulate. So if the angles are the same in a triangle, the sides are proportional. So if we think about this, and we think about this right triangle, so we have our hypotenuse over here, we've got leg 1, we've got leg 2, and with the Pythagorean theorem, we know that the length of leg 1 squared plus the length of leg 2 squared equals the length of the hypotenuse squared. So this case, it would be 1 squared plus 1 squared equals the hypotenuse squared. So 1 squared is 1, so this is really 1 plus 1 equals the hypotenuse squared. So that's 2 equals the hypotenuse squared. All right, and then how are we going to do that? Well, we'll just take the square root of both sides. So therefore, the hypotenuse is going to equal 1 times the square root of 2. Now, I intentionally wrote the 1 in front. A lot of times we would just write that as the square root of 2. But those two things are equivalent to each other. So over here it is 1 times the square root of 2. All right, let's try another one. Same thing here. Notice we have the 45, 45, 90. So again, that's an isosceles right triangle. And so here, instead of it being 1, the legs are 2. So it's going to be 2 squared plus 2 squared. This time I'm going to call the hypotenuse x. Equals x squared. So this is 4 plus 4 equals x squared. That's 8 equals x squared. Now we're going to take the square root. Okay, so 8 is not a perfect square. So what goes into 8 if we think about our perfect squares? 1, 4, 9, 16. Well, 4 times 2 is 8. So that we could write this as the square root of 4 times the square root of 2, which equals 2 times the square root of 2. Okay, so this equals 2 times the square root of 2. So what is the ratio of all of these sides in that triangle? Well, what do we notice is that in the 45, 45 triangle, let me just take a highlighter here to show this to you. So here we have 1, 1, 1 radical 2, 2, 2, 2 radical 2. So it's, if we simplify that down, you know, it's 1 to 1 to 1 radical 2 that we see in all those cases. So write the ratio of the side opposite the 45-degree angle to the side opposite the 90-degree angle. So it's always 1 to 1 times the square root of 2. All right, so again, the sides opposite. So to help you remember this, I've got a little song, and what we say here is find the value of the given side, set them equal and solve for A, substitute in for A. So what does that mean? Okay, so here we have a 45, 45, 90 triangle, and here's how I remember it. In a 45, in a 45, in a 90 triangle, it's A, it's A. It's A radical 2. In a 45, in a 45, in a 90 triangle, it's A, it's A, it's A radical 2. In a 45, in a 45, in a 90 triangle, it's A, it's A, it's A radical 2. So A equals the leg length, okay? The leg length. So we use A just because a lot of times, you know, X gets used in there. I've done this other years and you've used x as the variable. So initially, when we solve these questions, what we're always going to try and do is find a first and then plug it in to these things. All right. So let's go ahead and look at our next one, which is a 30, 60, 90 triangle. So consider an equilateral triangle whose side measures are 2 units. The altitude is drawn. Find the measure of all the angles. Okay, well, if this one is 90, this one is also going to be 90. Now we know that the large triangle it said is equilateral. So we know that equilateral triangles are equiangular. So that would be 60 and 60. And we're left with, what's the remaining angle? Well, we know that 90 and 60 adds together to be 150. So we know that these angles here are going to be 30 and we're going to be 30. Okay. Now, since both of these triangles are congruent to each other, or they have the same angles going on here, we could prove they're congruent. We know that these two sides have to be equal. So if the length of this whole bottom side here is 2, that would mean that x is going to be 1, which would mean that this side is also 1. So now we need to find the height of the altitude, h, and notice here that we have a right triangle. So I'll just highlight it for you. Okay, so here's a right triangle, and with our right triangle, I'll use a different color here to illustrate this. So here's our hypotenuse. Okay, here's kind of leg 1 and leg 2. So if we do the Pythagorean theorem, we come up with h squared plus 1 squared equals 2 squared. Okay, so h squared plus 1 squared equals 2 squared. So h squared plus 1 equals 4. So now we're going to subtract 1 from both of these sides. So h squared is going to equal 3. And then we'll take the square root of that, both sides, which is 1 radical 3. Okay, so the height of the hypotenuse is 1 times the square root of 3. So what is the ratio in a 30, 60, 90? Now here is the part that, in order to understand this, here's the part that you got to get. When we're talking about the 30, we're looking at this side opposite 30. So what is that? Well, the side opposite 30 is 1. What's the side opposite the 60? 1 times the square root of 3. What's the side opposite the 90? 2. Okay, so that is the ratio of all of those sides. 1 to 1 square root of 3 to the square root of 2. So question 5 says, what is the ratio of the side opposite 30-degree angle to the side opposite 60-degree angle? Okay, so let's go back. The 30-degree angle, the side opposite here is 1. To the 60-degree angle, that's our h value up here, which is 1 times the square root of 3. Okay. Write the ratio of the side opposite to the side opposite the 90. So that one is 1 to 2. Write the ratio of the side opposite 60 to the side who's opposite the 90-degree angle. So what's opposite 60? 1 radical 3. Opposite 90 is 2. Okay, so here's how I go about doing this. We'll kind of extend this song here a little bit. Again, we need to see opposite the 30, opposite 90, opposite 60. Okay, so the song continues. I'll just review the first one. In a 45, in a 45, in a 90 triangle, it's A, it's A, it's A radical 2. In a 45, in a 45, in a 90 triangle, it's A, it's A, it's A radical 2. When it's 30, it's A, 90, 2A, 60, what's that? It's A radical 3. When it's 30, it's A, 90, 2A, 60, what's that? It's A radical 3. When it's 30, it's A, 90, 2A, 60. What's that? It's a radical 3 and a 45 and a 45 and a 90 triangle. It's a radical 2 and a 45 and a 45 and a 90 triangle. It's a radical 2. When it's 30, it's a 90, 2a, 60. What's that? It's a radical 3. All right, so same process here. When we're going to solve a problem, we want to find the value of the side given, set them equal to solve for a, substitute back in, and simplify if necessary. All right, so we have a bunch of examples that we're going to look at here. And now that we've got kind of our relationships figured out, let's go ahead and identify those. Okay, so here we are. Find the value for the variables. So we want to identify this. We've got a 45 and a 45 and a 90 triangle. So what I like to do is kind of in parentheses, I like to write that relationship. So it's a radical 2. Now the question wants me to solve for h, but I can use this in here. So first step is solve for a. We've already done that. A equals 9. So 9. So now h equals a times the square root of 2. So h equals 9 times the square root of 2. We just take the length and we just plug it in, okay? That's kind of the easiest one, all right? Sometimes my 9s and a's look similar. All right, so B, simplest radical form. Same thing, we got a 45 and a 45 and a 90 triangle. It's a radical 2. All right, so we know what a is because we're given it. It's 2 times the square root of 2. So now x equals a times the square root of 2. So we're going to substitute this in for a. So it's 2 times the square root of 2. When you substitute, you always put it in to parentheses, times the square root of 2. Okay, if you have a calculator, this will put it all in. It'll give you one number. But here it would be 2. And then since the 2's are both under, that would be the square root of 4. Square root of 4 is 2. So x equals 4. Okay, that gives us the length of x. All right, one more. Now this one is the most the simplifying requires a little bit more. So in a 45 and a 45 and a 90 triangle, it's a radical 2. All right, so step 1 is to solve for a. So a times the square root of 2 equals 6. So here's how we go about solving that. Well, it's a times the square root of 2, so we're going to divide by the square root of 2. Houston, we have a problem. There's a radical in the denominator. Okay? So in simplifying, if we're going to put something in simplest radical form, we don't ever want the square root of a number in the bottom when we can't simplify that into being a whole number. So in order to simplify this, we're going to multiply it by the square root of 2 over the square root of 2. Now really, what are we multiplying by? Anything divided by itself is 1. So we're not changing the value, we're just changing the form. How do we multiply fractions? We multiply the numerators. 6 times the square root of 2 is 6 times the square root of 2. The square root of 2 times the square root of 2. Now here's the thing, whenever the radicand, that's the number under the radical, is the same, the answer is just that radicand. So if you want to do that in a longer way, the square root of 2 times the square root of 2 is square root of 4, which reduces to be 2. Now that this 2 is outside the radical, we can simplify that. So that would be 3 square root of 2, because 2 goes into 6 3 times. So we weren't being asked to solve for a, we were being asked to solve for x, but x is the same thing as a. So x equals 3 times the square root of 2. Okay, so these questions where you're given the length of the hypotenuse in the 45, 45, 90, that's where you have to do a little bit more simplification work, and this is called, we have to rationalize the denominator. Alrighty, so number 3, a high school softball diamond is a square. That's going to be an important thing for us to identify. The distance from the base is 60 feet. To the nearest foot, how far does a catcher throw the ball from home plate to second base? Okay, so what we need to recognize, well, a square has right angles, and a square is, all the sides are the same. So this is an isosceles right triangle, which is a 45, 45, 90 triangle. Got to identify that. That's how these things start to kind of sneak into us. Well, what is it? In a 45, in a 45, in a 90 triangle, it's A, it's A, it's A radical 2. All right, so the distance is 60 feet. Well, that's nice because we know what A is. So D equals A times the square root of 2. D equals 60 radical 2. Now in this case it says to the nearest foot. So in our calculator we're just going to go put in 60 times the square root of 2, and we get 84.8528. So to the nearest foot we would say the distance is about 85 feet approximately. Okay, so again, the key here is we have to recognize that half a square, all right, is a 45, 45, 90. Okay, and that's a common one that shows up here where this special right triangle comes in. All right, now we're moving on to some 30, 60, 90s, okay, and we'll kind of work through some easier ones to some more challenging ones. All right, so when it's 30, it's A, 90, 2A, 60, what's that? It's A radical 3. A radical 3. Oh, actually this one is a little bit, we get the challenging one here at the start. So again, the process is solve for A first. So A times the square root of 3 equals 5. So we're going to divide by the square root of 3. Houston, we have a problem. There's a radical in the denominator. We're going to rationalize you. We're going to multiply you by the square root of 3 over the square root of 3. Again, we're really multiplying by 1. We're just changing the form. So this becomes 5 radical 3 over 3. Okay, now that can't be simplified because 3 doesn't go into 5. So our A is really in this case what D is. So D would be 5 square root of 3 over 3. And F equals 2A. So F equals 2 times 5 square root of 3 over 3. You could think of 2 as 2 over 1. So that would be 10 radical 3 over 3. And again, 3 doesn't go into 10, so you can't simplify that any further. So here we started off with kind of the harder one first. That means the harder one is when you know the side opposite the 60-degree angle. That tends to be a little more challenging because we have to, again, rationalize the denominator is what that's called. Okay, so number 5, 30, 60, 90. When it's 30, it's A, 90, 2A, 60. What's that? Here it is again. It's A radical 3. All right, so I like this. We're challenging ourselves here right from the start. So A times the square root of 3 equals 15. We're going to divide by the square root of 3. Houston, we have a problem. There's a radical in the denominator. So we're going to rationalize it. Square root of 3 over the square root of 3. So we get 15 radical 3 over 3. Square root of 3 times the square root of 3 is just 3. It's just the radicand. Now this time it does simplify. So A equals 5 times the square root of 3. Okay, so A represents the letter G, 5 times the square root of 3. Okay, and now we have to get H. So H is 2A, and again, A was 5 times the square root of 3. So when we multiply those two together, we get 10 times the square root of 3. Alrighty. Number 6. I think this is our last one. An artisan makes pendants in the shape of equilateral triangles. All right, all the sides are equal. The height of each pendant is 18 millimeters. So the height is really what we think of as our altitude. Okay, 18 millimeters. What is the length S of each side of the pendant? So this is S. All right, well, here's what we need to see. This is a 30, 60, 90 triangle. All right, so what we have is when it's 30, let me get a different color. When it's 30, it's A, 90, 2A, 60, what's that? It's a radical 3. All right, so we're starting off here, and we need to find basically S. So we start off though always by finding A. A radical 3 equals 18. So we're going to divide the square root of 3. Houston, we have a problem. There's a radical in the denominator. So we're going to come in and rationalize it, and we're going to get 18 times the square root of 3 over 3. Okay, just keep the radicand. So this becomes 6 times the square root of 3. So S, which is the side, is 2A. So S would be 2 times 6 times the square root of 3, which is 12 times the square root of 3. But in this case, it says to the nearest tenth. So we're going to put that in our calculator, and we're going to find that S is approximately 20.8 millimeters. All right, that is the side. Okay, so actually, in these examples, we kind of did the harder of the two. So the key is for us to go back to, look at both of these, make sure we understand the ratios, and then solve for A and substitute it in to find the side that you're working on. Okay, so hopefully that little song helps you remember it, and you're going to have to work it out. Some of the simplification stuff takes a little bit of thinking through. So let's keep on asking. I'll see you back here soon.